Let's finish with 9.9 geometric power series. Example 6, find the power series that represents 1 over 1 minus 2x. Then find the interval of convergence. Well, we know 1 over 1 minus x is 1 plus x squared plus x cubed. And minus 2x, we can just replace every x we see with 2x. And we can therefore create our power series from there. Another way that we can do this is we can go through long division, 1 minus 2x on the outside, 1 on the inside, and we go through, determine the values for the quotient, and we see 1 plus 2x plus 4x squared will show up. Example 7, find a power series for 1 over 4 plus x. Now here, the issue centered at 0, and then find the interval of convergence, find the first 4 non-zero terms and a general term. The problem here is that this 4 is getting in the way of matching with this a sub 1 over 1 minus r. So we have to find a way, first off, to get the minus to show up, and then we also need that 4 to go away to become a 1. So first thing we can do, well, if we can, we know how to get rid of the positive. We can make this a minus a negative x. And then what we can do is, if we multiply top and bottom by 1/4, then we can cause this expression, or this term, to become a 1. So if I multiply every term by 1/4, the numerator will give me 1/4. 4 over 4 is 1. And then negative x over 4 will become something that we can use for our ratio. So in essence, our first term is going to be 1/4. And then each time our ratio will be negative x to the 4th. So we multiply each term by negative x over 4, and then we can see the pattern show up. And once we do that, then we can see that this will produce a general sequence of negative 1 over n, negative 1 to the n times x to the n, all over 4 to the n plus 1. We have to kind of play around with the exponents so that they will match as we increase the n value by 1 each time. Another way we can do this is, we know a sub 1 is the 1/4. We know the ratio is negative x over 4 to the n. So we can simply create it from here and then simplify it to be something that will match with looking at each of the terms individually. All right, we know this is a geometric series. And geometric series, we therefore know that our ratio must be less than 1 in order for our series to converge. So if we solve for x, we get x sits between negative 4 and 4, because, skipping a step here, this becomes x is less than 4, or the absolute value of x is less than 4. If the absolute value of x is less than 4, that means x can sit between negative 4 and 4, with the center being 0. And with geometric series, we know our endpoints will never converge, so we can simply jump towards parentheses from negative 4 to 4. Okay, sometimes we cannot center our function at x equals 0. In this case, we must try to rewrite our function with the new center showing. So example 8 says, find the power series that represents 1 over x centered at c equals 1. Then find the interval of convergence, include the first 4 non-zero terms and the general term. Well, we can go through this using Taylor series by the Taylor rule, where we find each of the derivatives and evaluate each of the derivatives at our center 1. Or what we can do is we can go to our geometric sum formula, and we can just replace the ratio with x minus 1, because we know that's the new center. Our center is at x minus c. However, we need to make this look like the 1 minus r, so we need to put a minus in front. If we do that, then that's going to cause, we have to make balance by keeping what's inside here as negative. So that means our ratio is now negative x minus 1. And if that's the case, then we can begin to create our series. So 1 over x, the same thing as 1 minus x minus 1 plus x minus 1 squared minus x minus 1 quantity cubed. We can actually use the Taylor series here, Taylor rule, to begin to plug in. So the first two terms are just going to be tangent rule, and then the second derivative evaluated at 1 is going to be 2 over 2 factorial times x minus 1 squared, and then the third derivative evaluated at 1 is negative 6 over 3 factorial times x minus 1 cubed, and we can simply simplify that. So the Taylor rule will produce the same thing as using the geometric rule for the sum. Okay, what we can also do is we can take the integral of 1 over x. The integral of 1 over x is going to be the natural log of x. And then the natural log of x will turn. We can also find what natural log of x is by finding the integral of each of these terms. And so a natural log of x can be represented by this power series, which we can develop from the 1 over x. And if we're missing the c value, we can find the c value by plugging in, because we know natural log of 1 is 0. So we replace all the x values with 0, and then we can solve for c. So c is equal to negative 1. Okay, two more examples here. Examples 10 and 11. So find a power series that represents 1 over 1 minus x squared. Hint, let's find out what integral of 1 over 1 minus x squared is first, and we can use that to help us. So the integral of 1 over 1 minus x squared, we can't expand using power rule. We have to go through u substitution. So if we let the u value be 1 minus x, derivative is negative 1, dx is negative du, negative 1 over u squared, we can bring that up and use the power rule. So this becomes 1 over 1 minus x. Okay. Now we know the integral of this is 1 over 1 minus x, and we know 1 over 1 minus x is simply a geometric series that we can represent as 1 plus x squared plus x cubed plus x to the fourth, so on. So therefore, if I want to find 1 over 1 minus x squared using this information, that means the derivative of this must bring me back to this a representative power series for 1 over 1 minus x squared. So the derivative of 1 over 1 minus x will just be the derivative of each of these terms. 1 goes to 0, x becomes 1, x squared becomes 2x, x cubed becomes 3x squared, so on and so forth. So we're able to create our power series by thinking, kind of working backwards to using the integral of 1 minus x squared, and then going backwards from the power series that we see here. Okay, last example, find a power series that represents natural log of 1 minus x centered at x equals 0, and the hint is let's try and find integral of 1 over 1 minus x. Well, the integral of 1 over 1 minus x, we know it's going to be, we can go through, it's just going to be a natural log, right? So the integral of 1 over 1 minus x, well, we know 1 over 1 minus x is x plus x squared plus x cubed. The integral of 1 over 1 minus x is just going to be the natural log of 1 minus x. And so since derivative of the natural log of 1 minus x is negative 1 over 1 minus x, we can therefore say that the integral of the negative 1 over 1 minus x is simply the natural log of 1 minus x. So here we have 1 over 1 minus x. If we find the integral of this, that will be representative of natural log of 1 minus x. So 1 becomes x becomes x squared over 2, x squared becomes x squared over 3. So here we have created the power series for 1 over 1 minus x simply by looking at derivative and integral properties to help us get to the result.